Hello YouTube, this is Dynamic FA. We were doing applicable programming for Palletizer. It was the number 9, but I need to skip the number to 13. I will show you last time we have done on the course first. Okay, this is the programming last time we made. So I'm gonna test. I'm gonna play the robot and we'll watch what we have done last week. Robot goes to back to the home position. Go back to home position. Not yet. Goes back to home position. Go down to the pickup. Come back and place. And product count. Adding product count. Okay. This was it. Now I'm gonna stop. So now what we're gonna do in the pickup, it doesn't have approval signal to go in to the pickup area. So first thing I need to do, add signal before it picks up. We already done the course how to add input and output signal. You can have a look at that course, then you will understand how I have added the signals here. So anyway, I will show you the new signals in the list. Digital input. So I have added DI01 box ready. Sorry, this is typo. Box ready conveyor. This is the entering signal. Robot get actually into the area and picks it up. Another signal. Let me have a look. Yeah, another signal. We don't need it. So we're gonna use flip on signal to attach the product. Okay. So first thing we need to do to add the condition, put it into manual mode, and then we can add here. We can add the waiting signal, pickup waiting signal here. So that means add instruction wait di. Okay, here. So we can add here this here, then r peak before r peak it'll wait for the signal from the conveyor. Another way we can do, we can add signal inside the r peak before the peak position. This one is the 150 mil higher than P pickup position. So this is actually the target before the pickup. And after this, up to here moves A, and from here to move this line to that line, move L. So we can add signal here. Wait DI here. You can ask me which one is better, but all depends on. So this one have to have a more motion to get down there, but this another one is just close, just before the pickup is stopped. So normally I do program like this, just before the pickup position. So I'm going to delete this one, the first one, edit, delete. So here additionally I have add some simulation to make it fancy. So this conveyor will work. I set up all the conveyor condition and also gripper condition. So let's have a look first. That's okay. We are able to pick up the carton. Now it goes there, back to home position, homing. Look at this. Go to home position, right? We got the robot is home position, and then now it's waiting for the carton, and then I can send the new carton. And fix it up, put it onto the pallet. I can send one more. And fix it up, put it onto the pallet. So this is the way before the pickup. So you just wait for just before the pickup and then put it onto the pallet. So now I have already taught the position of this is you when you see this one here, when it picks it up, this point, the pickup position is so bad. It had a collision and this one doubled up is so bad. So I have taught the position already. So we're going to use that. I have added two positions. I can show you here. Let's stop and reset. Clear all the boxes. Okay. Now I'm gonna put it into manual. I'm going to use the. I will show you the position. Let me see. Debug. Repeat the routine. Go down. Teaching. Inside the routine, I have two motion. Move J. P pick origin and P place origin. So I have two origin. So pickup position is here and place position of this corner of the pallet. This corner of the pallet. I did lined up. I can now I can use these two positions. So we're going to change the program. Yeah, let's change it pick first. So basically this is the normal P pickup but P pick origin. Okay, and this one too I want to use offset. Copy and paste, but this one is 150 mil higher, so I don't want that. Just change this number to 0. Okay, then this is same. You just pick. There's no offset. Just P pick origin. You'll find out why I use this one later. Okay, this one. Okay, this one also normal P pickup. This one will be P pick origin. Okay, this is done for the pickup. Done for the pickup, and then now this one is also this one normal P place. Now I need to change this to P place origin. Okay, and this one also I want copy and paste, and this number, oh sorry, and this number will be 0. Okay, and this number, this target also p place origin. Let's double check. P place origin, 200, 0, 150. That's correct. And p peak origin, 150, 0, 200. That's correct. Okay, that's good. And then we will test the program. Okay, robot goes back to home position, same as before, and then it will go back down to the waiting position. Okay, it's on the waiting position, and then I'm gonna send a new box. Oh, sorry, this is my mistake. Let me stop. Okay, let me try again. Okay, robot move to pickup position. Above the pickup position, waiting for the cartons. I'm going to set one box, and then once it stops, robot comes down, picks it up. It's a bit. Okay, picks up. Yeah. Yeah, I think this is all because of the graphic. Okay, anyway, I'll keep going. We'll fix it up later. So the most important thing is pick up here, and then the place position we lined up this corner of the pallet, just above the pallet. But this is not no good. Anyway, so we'll fix it up anyway. So I'm going to stop. That's how I taught the position. And reset. Okay, then another thing we need to do, we do always same spot, same position. So this is no good. So I can show you this this one here. This is carton. I'm going to show you the size of the carton. This is important. Okay, look at this. This one is 380. The length 380, width is 290, and height is 200. Height is 200. So I want to keep this number inside the program. So we can add data, num data, show, new. Okay, sorry, we put it into manual. I'm going to add n box length, not variable. It's every time you turn off the controller, variable will be loose. you lose the data. So this one I want to do persistent data. So always keeping even power after the power up and down, still got the same data. So this is persistent. I want persistent, and uh, another one is width. Okay, and one more, height. Height. Okay, this is the information of the box length, width, height, and we need a we need a few more numbers, but I'm going to add only one first. Okay, add new. This one is n y position. Okay, this one it's okay. You can use a variable. Doesn't matter. This one. So we now we're going to enter the number. Height is 200. Okay, and length 290. Okay, and width 200. Sorry, 380. Okay, now it's ready. So what we want to do now, now before it always robot pick up the carton and then put it onto the same position, but now we don't want that. We want to the box in the its own position, like a palletizing, not just stacking onto the same position. As realistically that's not gonna happen. You're squeezing the box. This is just a simulation. So what I want to do here, uh, pickup is the same, but place, we need to do some calculation here. Here, about here, this one here, underneath it, we need a calculation. You go to math. Where's mathematics here? We need some calculation. Ny post equal cross this one multiply this one comes here, then long way that way, that means this width 290, that means where's this one and box width multiply we have product counter, below. That means the first one, first carton product counter number is 0 because we add number here. We initialize the product counter in the initializer routine, and then we first one have to be 0, and then second one shipped one box and one and shipped one width, and then two width, three width, fourth width. So we do like that. So what we want to do, every time you want to shift y direction, y plus direction, that means that's the way how we can shift. So that means we just change this number to ny post. Okay, and this one too, and Y pose. Okay, and this one too, and Y pose. Okay. Okay. Now, if we start the program, then it'll palletizing here, there, something like that way. We only programmed it that way. So we'll see what's happening here. Okay. Okay. Yeah. Right. And robot go back to home position. Okay, waiting for the cartons. I'm going to send a carton. Stop. Robot goes down, picks it up, and then put it onto the first position. Put it down, come back, and waiting for the another carton. I'll send one again. Come down, fix it up to the second position. Oops. Oh, something wrong. Calculation is not right. We need to double check it. Okay, I'll do one more and then we go back to program and check it what the problem is. This is not right. Let me stop it. Stop. And let's have a look at the program. Uh, that's this one, M box width. Let's see how much is the M box width. Oh, yeah, that's why. Okay, this one is this is my mistake. This one had to be 380, length 380. Okay, and this one is 290. Okay, okay, okay. Let me try again. Reset the memory and restart. Okay, now robot is waiting for the carton. I'm going to send one. Okay, go and stop at the position. Ah, this is again. This is just the simulation timing. I need to change some. Oh no good. Let me stop. Okay. Okay. Start again. Okay, let me try. No good. Okay. Now will be better. This is just the timing of simulation. We're not studying simulation. So let me try reset and that. Okay, okay, I got it. Yeah. Let me stop reset because of this one. I need to run this one. Reset, reset, reset. Reset, reset, reset. Okay. Let me try again. Yeah. Yeah, that's good. Because I made it the simulation pressing the button. Yeah, good. Go back at the waiting position. So this is how we can program it. We can shift X and Y position, then we can do the palletizing. So today we just shift it to the Y side, and the next time we can shift an X and Y, so we can finish the palletizing next time. So this is all for today. Uh, Thank you for watching. See you next time. Bye.